Hello everybody. Hello retro coders. We're back on the beginner level assembly language coding tutorials for the Z80 processor, specifically the one inside Sinclair ZX Spectrum. Again, I'll stress this is beginner level, and I'm going even slower this series than I was before. You might have noticed I'm back in my main environment, my main dev environment. Some problem on my screen there. There we go. Yeah, and I'm running out of screen space on my computer here, so I've enabled the ability to show web pages in this new environment or the old environment. So I've moved our previous code file into my other profile here. So all this is textmover.asm, which we made last lesson. And for this lesson, I think I mentioned already, I'm keeping it a lot more structured. Each lesson is going to be hopefully less per lesson, less information and less of me messing about. So I am still learning these. It's an ongoing thing. I'm going to keep making these videos. Today what we're going to learn is changing the existing character set into, well, changing it's the wrong word. We're keeping the other character set as it is, but we're adding our own user-defined graphics set. They're all 8x8 characters. We can make them look however we want as long as they fit into an 8x8 square. You could use photo editing software to make these if you like, and then find a way of exporting it into what I call it a bitmap. I believe it is a form of bitmap, but we're just going to make our own. They're only 8x8. So we can pretty much get into it. Continuing in this lesson, I am going to keep all this on one file because I was tempted to split this up and show you how to include other files into your main project, which will be coming soon, but it's not very big right now. I don't think it's needed. I don't want to confuse anyone who's just starting out, just for the sake of it. So as you can probably tell here, if you bring up what we were doing last time, this is where our data begins. This is our our data, and above here is our logic. Data can come in all kinds of shapes and sizes. It could be an audio file, it could be a whole sprite sheet containing 50 sprites, or it could just be one number for a position of an X position on a screen. However, they are always, when it gets boiled down, they're always in binary. So you could just as valid like that. Note that I've got a percentage sign there. That means that it's a binary notation. Same as I could have gone OXO. The OX is a hexadecimal prefix for hexadecimal notation. And as you go, you'll learn which one is more relevant for every time you're using it. The reason I showed you about the binary is it's not going to be needed immediately, but we're going to be doing bitwise operations in the next lesson or very soon, and it's something that I struggle to explain personally. I've now got to grips with how it works. I believe I know most of the ins and outs of it, but to actually coherently describe it to people on air without having any questions back at me, it's quite difficult. But I'm going to use the internet to help me with that and show you some websites. So let's get down to it, right? Here's our data, and that's what I wanted to do. I like to comment and just put data. You can, name it whatever you want. Variables maybe. I get told off for calling them variables, but they're variables, man. And these are constants, because they don't change. Excuse me. So I realised I didn't really, I glossed over these. For an absolute beginner, I'm going to put, I don't want to complicate, but dB is defined byte. That defines an 8-bit value. So as we see, that if we wanted, why would we want a 16-bit? Let's have a think. I mean, for example, when you get into advanced topics, you can do floating point numbers. So you can move 0.1 of a square. I don't know how that works with the spectrum. I've never done it, but you do need maths where it goes over 256, and you need to be able to do floating point variables as well. But like I say, I'm already starting to get sidetracked with my own rubbish. But where was I? Let's get down to adding UDGs. UDGs are user-defined graphics. There's a space for them. In fact, let me find out how many spaces there are. There's 21 spaces. Or if you're on 128K spectrum, you only have 19. These spaces are just areas for these 8x8 sprites to be stored, just like the letters A, B, C, D, E, F, G, and so on. They have their own memory address in the spectrum. You could also change them, but again, I'm not going to get waylaid with that right now. So you need to, in order to create a UDG, or in order to specify it in the program and use it, you need to create it. So we're going to start one up called U. I'm going to use lowercase just because the rest of them are. UDG1. Now a lot of examples are going to show you it like this. And by the way, I went on about labels the other day. You can just as validly do that, but for some reason, and I have done it there, haven't I? Oh no, that's in the wrong area. Yeah, you might notice for what I call variables, they don't have a hyphen. It's just personal preference. UDGs, we're not going to, once we make them in the data, we don't really need to look at the data much, so I'm going to put it at the bottom. Sorry about that, my full stop key is binded to my mute. Yeah, so we're going to want an 8x8 character here. So we define a byte. If we define it all ones, for tidiness, I'm moving it down the line. And I'll copy it 7 more times. Okay, there's an 8x8 character, and that's all a black square. And in fact, I'm going to make use of my internet page here. Alright, forgive me for the amateur style of how I'm showing you this, but I don't have a great computer and I haven't got much space on the screen here. Anyway, this is fine. So they come with some UDGs as standard, and if you're really clever, the other day, you would have, or yesterday in fact, you would have seen them. But look, we're going to look up ZX Spectrum character set. Bing will even find this. And here it is. There's the UDGs. That's just ones that they happen to have made. We've just made that exact same one there. Look. And as you can see, it actually has its own address on the ASCII table. So you can use them automatically, okay, without having to do any code. With the code I already showed you yesterday, you just use a different ASCII value and you would have got those. And you can probably create borders with it and do all kinds of funny stuff, to be honest. You could make a game with that. Now, what we want to do is a little trick that you can't really do in BASIC from what I read. It's exclusive to assembly. You can repoint that part of the memory where the Spectrum expects those UDGs to be, and you can just change the address. So as you see, we've already just created some data and that has its own address. So if we want to poke that and make that the first UDG, then we can specify several after that, and they'll just go in numerical order as they go, you know, as you would expect, like an alphabet would. I deliberately chose not to go into image editing. That's another lesson ahead. But if you want to jump ahead and do that, for example, you can see I'm making A by hand here, the letter A. But if you wanted to jump ahead, oh god, I've forgotten what I'm saying. Oh, I do apologise. Oh yeah, if you wanted to jump ahead, you can download something called ZX Paintbrush. That has a fantastic export functionality, which allows you to export an image, and it will, if you set it correctly, you'll get that as a result, you know, exactly like that. So my code that I show you here will work straight off the bat. I am gonna show you that soon, within 1 or 2 lessons, but not this lesson. Because for now we're just happy getting anything. We're going to be happy getting anything on the screen. Okay, so I've saved it. Yet again, I'm going to copy the path, press CD, change directory, delete that. You might notice my file path has changed. That doesn't matter. Just move the files. Let's try and compile it. I mean, it's always worth doing this anyway. I've actually had it before where I've come back to one thinking I've never changed anything, and somehow it doesn't compile. So the last thing you want to do is add a load of code and then find it doesn't compile and you don't know why. But that has compiled. And I'm going to say it again, like there is ways to debug code normally in modern coding environments. It's all built in. You'll have an event log, a debug log, warning log. You'll be able to produce text on the screen as a debug message. There's breakpoints, but I haven't even got into any of that with the Spectrum. I'm not at that stage. There are other ways to debug. You can just do trial and error with moving things and drawing things and see if they show up where expected and stuff like that. Anyway, rambling on again. So we have one user-defined graphic down the bottom. My mouse wheel doesn't want to scroll. So just one time at the start of your program, if you want to, you may want to do it during a different level change. You could do it again to get some new UDGs in there. But we just want to set them once. So we'll use the 16-bit register HL and point it at our UDG1. That's an ugly looking word, isn't it? Halogen. HL equals pointer at our UDG1. This piece of memory here, you just need to know. That's a memory address, and as you'll see the brackets around it. That means we're accessing the data in that memory address, and we're setting it. No, in fact, completely disregard what I just said. That would be the other way round. For example, here, that's what we're doing with the bracket. But when the bracket's on this side, we're actually we're repointing the data from that address to this new address, which is in HL. So yeah, I confused you there. If we'd have done that, that would have put because we haven't we'd have done that. HL would have contained the first 16 bits of our UDG, and it just would have put it into that memory. But instead, what we've done is we've took the address of that memory of that data, and we've pointed this into that. So because that address there normally contains a memory address. Okay, so we've just changed the memory address inside there, so that it now points at our UDG. Again, this is stuff that it's not really logical. You just have to know that number. It goes back to that school kid ROM disassembly website I showed you about. That will be listed there. But remember, this is a decimal value. He does it in hex, so you don't get caught out with that. Alright, so we've repointed the change pointer in. So I hope you can read that comment. It just says it all there. We can use this existing code because we've got player sprite here. So let me get my calculator, because I've made a mistake with hex before trying to do it off the top of my head. I don't want to do that again. Yeah, so they begin the UDGs at code 144, which is hexadecimal 90. So we've just repointed that hexadecimal 90 to point to our UDG. So I believe this will actually, we could literally just do that and we should have this as our player sprite now. Oops. And there you go. As you see, 8x8 sprites are not particularly big enough. It's a real shame the Spectrum doesn't have any way of having larger sprites. But that's looking exactly right. Okay, so now, I mean, actually, we could have just put the UDG there, yeah? Let's make sure I haven't used it somewhere else. There we go. Okay, so I've changed it so it's just now it's going to be an array, or what I call an array of UDGs. So we don't have to name them all. They start at this memory address. I'll put a comma there, a semicolon, because I like to space them out. That's the only reason. But then we'll do another one. Let's just make it a face. Okay, so I've got a rudimental face there. Now, that's just 91. And there he is. I didn't outline him. He looks a bit skew-if, but that's just the way I've made it very quickly here. Hey, he looks a bit better now. So what I was trying to highlight here is how this is just a memory address. You've defined 8 bytes and then another 8 bytes without any name. Okay, but it doesn't matter that, because this is pointing to the first memory address. That's fine, which sits at 0x90. That expects 8 bytes, so it'll find the first ones, and then the next the 91 will automatically be pointing 8 bytes further down. Just the way it works. So obviously you can make another 21, well, a total of 21 of these and use them in your game. You could of course have these could be called level, or you could have down here level 2 UDG, and you could just do the same thing, and then just when you change to level 2 you just call that and put level 2, you know. Right, so I think there we've covered UDGs just very briefly. Again, they're really useful, but I don't use them in my game. Didn't make a complete game. What I made was the first level of a horoscope skiing clone. I did not even add the collision detection. I just added like randomized cars. I added the shop at the bottom where you could go and get something, and I didn't use any UDGs, you know. So, but there are games out there, like even commercial ones from the early 80s, that only used UDGs. Because there's only 8x8 doesn't mean you couldn't have a player 16x16. You'd just have to use a few of these, and you'd see a lot of breaking probably in the sprite as you moved. But then you'd have to move one character cell at a time, exactly, not half a cell or whatever, and then you'd probably find there was no breaking or anything. Same goes for your background and your walls and stuff like that. You could just use 2 of these as a thickness of wall, and you could have like all ones there and all zeros, and you'd be able to have half a thickness, so the wall would look 1.5 thick. But again, the collision detection most likely will still go by character, so you can do per pixel. Like you could do a collision check, and then you could check is it 1 or 0. You know, there is ways of doing that. So anyway, I'll get sidetracked yet again. Don't want to do that. The thing is, we've covered UDGs now, and if you don't understand them, please write to me. I will do another video if I have, if there's anything I haven't done properly, or I could maybe just answer a simple message in the comments. Anyway, and I do want to stress, this is the very early stages, and lots of this stuff you won't need to know. You eventually, especially the inbuilt run routines, you don't always need them. I'm showing you how they work now, and you'll probably forget most of it. You won't need it all, but you'll be able to hopefully get the book I've got, or look back at this video and other videos that I make, and if you need them, you'll be able to locate what they are and use them. But like I say, most of the time you'll be creating your own graphics and coming up with a way of drawing it pixel by pixel. The next thing I want to cover is just displaying numbers. Now, if you've watched my other videos, there's a better way of doing this, where you use ASCII and you have, like, say 5 numbers. That would allow you to go up to 99,999. You do each number separately, and you increment the further ones up. When they reach 9, you reset them and increment the one up yourself manually. That way you never have to worry about the size of the value, because obviously like a value of 99,999 is too big even for even for a 16-bit, I think, even for a 16-bit number, it's 67,000. But I might be wrong. Maybe if you do it unsigned, I don't know off the top of my head. But basically, trust me, that first way I showed you is better than this. But the Spectrum also has a built-in function, and it'll print a number up to 9999. After that, if your number increases over that, it starts distorting into whatever character it feels like. There's all sorts of weird characters it could be. So if I look this up, yeah. So the first way is the worst way, but the easiest, and it only goes up to under 10,000. So you'd have to come up with a way of making sure your score isn't going to go over that, or whatever the value is you want to display. So we'll do it here. Score. dB, obviously. Whoa. I think I got halfway through explaining this earlier and didn't. Other than dB, there's also dW. That's defined word. Now that's a 16-bit bit of data that it's expecting. Now you can still just put 0, that's fine, but 0 is actually equal to, instead of just that, it's, you see, or in fact, I think that's the one. I haven't actually tried it. Maybe you have to do that, but I don't think so. I think that. But anyway, that's equally valid. Just writing 0, and we haven't got anything to change our score just now, so I'll just write one. We've got a score of 1, 2, 3, 4. Now look how simple this is. If you just want to display, you obviously could, let's say every time you move right you wanted to get an extra score, you could increment score by loading it into A and incrementing it and putting it back. If you want to display the score, I'm going to change this name forever now. That was the display, it was a loop. I'm just going to call it main. We're going to load the BC register, the value inside score, BC equals score value. And then in hex, we're going to call the function 1A, 1B. Built-in routine, prints integer less than 999. Less than or equal to. Now, this is preference. I go on and on about this, but it's because this is aimed at the beginners, and they might still be struggling, some of you, so you never know. Maybe you don't understand why the hell am I writing it like that. That's exactly the same as writing 6683. Exactly the same. It's also the same as writing OX 1A 1B like that. A lot of people like to do it like that. And it's also the same as oh god, there was one more I wanted to show you and I forgot it. Oh yeah, it's also the same as writing this. Okay, look how horrible that looks, but you could, that is another valid prefix, so that they will both compile and do the same thing. So that's it. I don't know, we haven't set the position of that or anything, so I expected it to be in the top left corner. Excuse me. I'm going to move my guide down just for simplicity. Oh, it's cut. Oh, of course. We used, excuse me, my throat's going. We used the at command earlier in the loop, and we never set it again for the BC, so that's quite good. Set pos is actually player specific because it's not asking for an input, so he has a slightly more advanced thing. We could have said input and make sure like B and C have the X and Y position that we want to set, and we could have made this a generic function which would set position to anything. Should we go ahead and do that? Is that a bit too convoluted? Let's do that. Let's make that example. Okay, so this is going off sidetracked again, which I tend to do. In this sort of scenario, what I tend to do is copy, because I'm going to change it. I mean, I use version control, but that's way advanced for what you'll need to do. With mine, I've noticed with some versions of VS Code this doesn't work, but I'm highlighting it, I'm holding control and press K, and it does that. That might be because of the extension. I'm using one of these. Look, I've got 3 on there. I don't even know which one I've got. So you might want to look at them if yours doesn't work. Because I noticed when I went into that other environment that didn't work for me. Anyway, so we've got that valid version of that. So now we can work on this one happily without worrying too much. Okay, so I'm thinking in my head that I want to use the B and C register to store them. That's fine. We're using it there, but that's separate from this loop. So B and C is not being used in the loop. It's not being used to count something or anything like that. So it doesn't actually matter which one you use, although it can do later down the line. You suddenly think, oh, I need B for a loop. You'll learn why soon that B is a bit special for loops. But and then you think, oh, I've got to go and change all them to DE, which can be a pain. But same, let's change them to D now. It doesn't make any difference for this particular one. Okay, so DE will equal XY. Is that clear enough of a note? Desired XY. Yeah, that'll do. Alright. So instead of loading Y there, or A with Y, I want to load A with E, and that one with D. Now all I have to do is make sure that when I set position for the player, make sure that D and E equal those values. I'm going to bring up Z80 Hev in a second because I want to look at the load. The reason I want to look at the load, I'm not going to show you this because it's just pointless. This is a quirk. DE is a 16-bit register. It's two 8-bit registers in a pair. These two are side by side. Put them that way around. I've seen why. I've just learned why people are doing it that way around. Although you don't need to. There is another way around it. In fact, I've already done it the other way around. That's good. I'll change that around. Because they're already in a line to each other, yeah, you can just load D with X. That actually should load D and E, as far as I'm aware, with X pos, Y pos. So although we've only asked to load D, the side effect of that is that E gets filled with the other data next to it. And I think I'm working away from the book now. I'm on my own here. I'm pretty sure that is the way it goes. And if it isn't, we'll have to find another way around it. But as you can see, this should be enough. What have I just done? That was the wrong place. Okay, this if you copy my code, I'm cutting that. It was meant to be above this set position. Okay, and then we're going to want the exact same line above this set position. And then here we want it. Well, we need some. Let's make it easy on ourselves and put score X. Do you know what? Score X pos. Let's make it as clear as it can be. 0. Score Y pos. DP 0. Alright. So we can just copy what was done there. Load D, but this time with the score X pos. Call our set position function, which in turn calls at and sets the new position for the score, and then everything should continue as it already was. So I'm confident this is going to work. That's been commented out, I'm sure you're aware of that. So I could delete it if I wanted, I'm not going to. I'm going to compile. Oh, looks like a non-existent instruction sheet, and there's actually a few of them. Line 13. So I've done whatever I've done, I've just copied the same error over and over. Oh, okay. Let's try that. See, I get confused with pointers myself. I might have to. Yes. Let's hope this works anyway. I think it will, but who knows? No, it certainly doesn't. Right, damn it. I thought we could load D quickly in that manner. I think it might actually be you load the whole 16-bit register with the value in XPOS. That's what it is. So I apologise. What happened was, where I was explaining earlier about how it just went to the next byte along, I was wrong. I think this will work now because it's a 16-bit register. We've added the 8-bit value. It goes and gets the next 8 bits as well. So what had happened was I just put D, but actually we're loading DE. And it looks odd because it looks like I'm loading it with XPOS. That's what it is. I'm quite confident this will work now, but let's check. It does work. Although our position seemed to fail. Something happened. Something went wrong with our guy. He's going down instead of sideways. It's just a backwards thing again. And that's because you're going to need to read that book I showed you, because I need to read it as well again by the looks of it, because the DE, like the registers, the high-low is actually the other way round on some of them, most of them. I can't be bothered to read it on air, but it's either the HL or all the DE and BC and all that. They're the wrong way round. Anyway, all we have to actually do is look at our set position, just switch it, load that to D, and that's to E. This should do it now. Yeah, there we go. Oh, I'm so sorry I've missed your messages. Damn it. I had a viewer there and I was too busy working. He's asked a question, but oh well. Oh, hello, mate. Yeah, good to meet you. Yeah, what I'm working on briefly is very basic level stuff. I've got some previous videos, especially on my YouTube, where I jump ahead of it forward a bit fast, in my opinion. And this one's a much slower approach. Right at this moment, we're looking at converting UDGs, which is user-defined graphics. We've repointed the memory so that it points at our own UDGs, which we've created here, and what they are 8 by 8 pixel sprites. So it's enabled me to draw whatever little sprite I want, just out of ones and zeros. Very basic stuff. The 1, 2, 3, 4 there is a very simple routine, which is built into the Spectrum to write numbers rather than because if you try and write a number normally, you'll get a text value that's assigned that number. Is my YouTube link broken? Oh, thanks for letting me know. I'll put it up now to. Yeah, I'm very new to this, as you can probably tell. Yeah, for some reason the only link I could get off the top of my head is very long, but that should definitely be valid. I'd well appreciate a follow, mate. That'd be. Oh, and thank you for following me. Yeah, I've just noticed that. See, I am going to get notifications done where I get a text alert. When you text me, I'll get an alert, and when you follow. But I haven't got around to that yet. I do work a lot of hours in the week doing other things as well. The very next thing we're doing, and it's the last lesson of the day. Oh, nice one. Yeah, I mean, the YouTube's a little bit of a mess, but there's another series somewhere in them playlists. It's called it's not the top lot playlist. Where that? It's a real mixture. Yeah, I do apologize. If you check back there this evening, you'll see some more coding playlists because I'll tidy that up. But, what am I doing? Oh yeah, the very last thing we're going to do today is learn how to colour the screen. Obviously very important for games. So this is one of the great things about assembly language. We can just write directly to the memory where the screen colour is stored, and change it. So if I go back to our main function, I don't know your level of knowledge, but what I'm doing, LD here, is an instruction, part of the assembly language. There's not that many instructions. That's what I love about assembly. It's not that many, and you can learn them all pretty quick. BC is a register, which is part of the. Oh, okay, cool. You probably know a lot more about it than me, then. To be fair, I've done lots and lots of high-level programming on C# and C++, Unity, Unreal, all that sort of stuff. But oh, do you? Okay, cool. Oh, excellent, mate. Thank you. In that case, let's try and make this screen change colour. So I'll load the A register. I'll get my bitwise calculator out again because I do not want to fail that. A lot of pros, like a lot of experienced coders in this, they just use decimal. They don't bother using. They know all the binary straight away as decimal, and the same with the hex. Have you ever seen Spectrum color memory map? Because I should probably show it on the web really quick. Yeah, let me load it up. Let me do this. Because everyone who hasn't seen it will need it. And I'm just about to change it now. Rather than working in numbers, we're going to be working in binary here. Trying to find the one really good website. This one will do. Okay. So this is what we're looking at here. That is of course a byte. Yeah, hex is easy. I mean, I make mistakes at it sometimes when you've got like a long number in hex, but obviously I know how it works. It's not hard to understand that, in my opinion. Same with binary. That's the thing. Binary is just the same, isn't it? It's just harder to calculate, like just by looking at. But this principle is exactly the same. Anyone who doesn't understand this part here, I'm just going to briefly summarize it. Hopefully you can read the web address and go there. But this is a byte, and it represents one cell of color on the screen, which is 8 by 8, which is where our UDGs are fitting, for example. But every character has a 7th bit. Bit 7 is a flash bit. Just ignore that for now. It means it will just literally invert these over and over. B is brightness. Now, if it's not a border, if it's an in-game color in the middle screen, they have two varieties, bright or not bright. So that would obviously be 1 or 0. This here, bits 3, 4 and 5 are paper, and with 3 bits you can go from 0 to 7. So that's giving us 8 choices only. Okay, and here finally is the ink color, which obviously paper is background, ink is foreground. Now the weird thing is, if you wanted to do a color 1 1 1, which would be 7, and then you wanted to do ink 0 1 0, which is 2, I think, off the top of my head, you'd have to add that to 9, and then if you want to add the flash, the decimal number becomes a silly number, you know. Yeah, it's really clever, this. Honestly, I was fascinated with this, because they've managed to make just 8 bits for a whole character down here, and then 1 bit, or byte, sorry, 1 byte for the colour. So in 9 bytes you've got the entire coloured character. I really thought that was quite clever. And yeah, so obviously you seem like you're going to understand all this straight off the bat. Like, you can just call these decimal values, and even if you've got the flash bit set, you know, you can just add that value to it and the computer will know what colour you're on about. But I don't like to do that. What I like to do is let's make a constant, actually, because it never changes. So it's blue ink, yellow paper. I'll call that attribute. So we know that's what it is. Define by transistors. At the end, physically, each 8-bit is stored at a register. Yeah, that's correct. I mean, I didn't know about the transistors, but if you saw my other video, I showed you the book with the elf in it. That one it's a fantastic analogy, and that's how I know the Z80 now. It's like, basically you've got the 8-bit registers, then it's got two 16-bit ones at the bottom. I can say I'm only a beginner myself. I'm not like a student of any kind, you know. I'm just a hobbyist. But that's really interesting. Yeah, I'd love to know how to make my own processor. I did see someone making an Amiga, the very first Commodore Amiga that was made. It was made in a hotel by some bloke. It was like a breadboard, massive thing, huge it was. It was walls and walls of it, and he had to, like, imagine a book that was the size of a wall, and you could add pages. It was like that. Interesting stuff. Anyway, yeah, from this book that I'm working off, number 49 is that, yeah, which happens to be 00110001. Can't scroll when I'm using OBS. It's not the mouse, because it's fine when I'm not streaming. Yeah, thanks, man. I've been learning lots, many years, for loads of different systems, but I've never. I normally run into a problem that takes me so long to figure out on my own that I give up, or you know, by the end of it, I've had enough, you know. But if I had gone to college, when I was a youngster, the college classes weren't, you know, the teachers didn't know anything about computers. So yeah, there was a computing course, but it had like 8 people in it, and I think, from what I've heard, it wasn't even any good. You didn't really learn much from that. I would have loved to have gone to it though. Yeah, so we're doing the same thing anyway, where we repointed the UDG memory. We're just going to repoint the colour screen memory to our new value. Although, no, hang on. Do we want to do that? Oh, of course, yeah. So back on our ROM disassembly, we would be able to find out that address 23693, which is actually very near the UDGs. That's our screen colours. Where do I load 8? Oh, there. It's a constant, of course, so that's why I didn't use the brackets. I'm sure you realise that. What value did I say? 23693. So we can just poke that value straight into there. And then just clear the screen to enable it to redraw. 3503, what's that in hex? Ah, the DAF, there we go, I knew it. So I haven't been quite so generous in my comments recently here. I think most of that's self-explanatory. Poke that value into the screen color attributes memory address. Yeah, that makes sense. I'm going to make a GitHub today before I go work, and I'm going to post some links to it on my different various sites, because my intention is that people can in the end work along with my code, and we're going to make some actual rudimental games, which then I'm hoping will have a bit of a community and people can add to it and put it, you know, the GitHub will be public, so you'll be able to just post your changes to it, you know, as a fork or whatever. Or just a copy, you know, you'll just be able to copy it in the folder. I'm expecting this to work now. This should just change colour. No. Oh dear. Damn it, I hate it when this happens. Yeah, I'd love you to, mate. I'll make sure I get the GitHub on tonight, because I've been meaning to do that, and I just end up gaming instead, playing some random games. But I've had problems before where I follow everything by the book, and the colour seems to work sometimes and not others, and I haven't been able to figure out why. There we go. But It's not the right colours. Excuse me. I think what I will do is end it here, because I don't want to have the end of the video be me messing about, and it's only to get the colours right. What I will do is figure it out first, so I can come back and concisely show you what I was trying to show you. That was only meant to be as a little bonus to the end of the video, to be honest. I just wanted to show the UDGs and the score today. My previous videos do show you a more advanced way of doing the score that is better than that, so I would check that out. I'm going to get to it as well if you're patient enough. Definitely, I've got 3 days off starting tomorrow, and I'm intending to do at least like 5 or 10 more of these videos over that time, maybe 5 if they last an hour. But yeah, I really appreciate your watch. Visual Studio. Oh, overlaps. That's me. Are you talking about on my stream? Yeah. Basically, I minimalized the web window rather than closing it on OBS, if you know what I mean. And I've got a bad habit of resizing my Visual Studio Code, and then that messes everything up. But I do apologise for that. I'm slowly getting there, I'm slowly working there. But I'm working with small screen space, so to see your messages, Oh, and the code. Okay, cool. Oh, the flickering. The flickering is caused by this clear screen being called every frame. There's ways around that, but this is just, you wouldn't do this in a real game. But this was just to make sure that the colour kept changing. I should have just changed the colour up here, to be honest. This should happen once now. Yeah. But I don't know why it's green and black, is it? Yeah. Should be blue and yellow. I mean, it's almost certainly this, isn't it? I think that'll be white on white now. Or it could be black on black. Let's just check it even works. It hasn't done anything. It will be something silly that I've done wrong that's causing this. This ain't going to work, but I'm going to try it anyway. That's an equally valid statement. Let's see if it works. Oh, it has worked, yeah. So I knew it was black or white on white. I wasn't sure which way around it was. So the constant was the issue. Wonder why? As far as I know, there's no difference in using that constant. I thought, my understanding of it was, at compile time, when this occurs, that just gets converted straight into that. All it does is take that and paste it, as far as I thought. I know this won't work, but I'm going to try it anyway. This will say incomplete statement or whatever. I can't remember the exact wording now. Oh no. Okay, it works. Awesome. Did I not make... Oh, I know what I've done. I'm an idiot. Every time, I'm so funny in my videos, man. I make a mistake right at the end and then fix it. Um, it's like I do it on purpose almost. What I've done is I've defined byte. I've like used my convention of a constant, so I thought it was a constant, but I made it not a constant. That there now, that's nothing. The compiler copies and pastes that value for me now. So that will work now without this bracket. But we don't want white on white. Let's have as a one last quickie just to finish it off. I'll load up the screen where it shows us the colours and we can see if it works. Damn it! I wanted the site. There's another site that shows you that and the other one on one website. Oh, this is it. There we go. So let's go for yellow paper and magenta ink. Might be the wrong way around. What have I done there? Oh, I closed that website as well. That's the flashing a bit. Oh, there's one too many bytes. One too many bits. Whee! I'm happy with that. Of course, it's nothing special. It wasn't meant to be, but we finally got it. The next session will be tomorrow, but what's going to happen in that? Oh yeah, I'm 100% getting straight into keyboard input. So we'll move this little guy around upon key presses and joystick. We'll be doing both, and that's the whole lesson. And then the one after that is sound effects, because I'm trying to keep it fun and snappy, a little bit varied from what I've already done, and I'm following more of the structure of the book I learned it from. I've really enjoyed having you around, man. Let me read your message, sorry. Do you like it at the top, dear? Yeah, no worries, man. I'll stick around and chat if you've got time. That was an interesting statement you just made there. I've always learned to put them at the bottom. Obviously, it makes no difference, does it? But to be honest, I normally separate all this. Like a lot of these will be separated out into another file. In fact, perhaps, but before we start the keyboard input, I'm going to completely tidy that up. Nice one, man. Nice one. Yeah, well, I better get going. I've got work later. I'm going to make a little gameplay vid before I go work. But obviously, I can't do too much coding. I'm not, not a pro. So, yeah, I'll be really enjoying speaking to you, mate. I'll be back on soon. Have a good night, mate. See ya.